Magnetic flux through a plane surface is the product of the magnetic flux density normal to the surface and the area of the surface. The magnetic flux density is defined as the force per unit length per unit current acting on an infinitely long current carrying conductor placed perpendicularly to the magnetic field. Faraday's law of electromagnetic induction says that the magnitude of the induced EMF in a conductor is directly proportional to the rate of change of the magnetic flux linkage. Lenz's law says that the polarity of the induced EMF is such that it tends to produce a current that creates a magnetic field so as to oppose the change in magnetic flux. In mathematical form, EMF equals to minus d phi dt. The system here is defined as the two metal rods and the connecting wires. So the free body diagram looks like this. Okay, first you have the contact force on the wires by the wooden support. Then you have an upward electromagnetic force due to the conductor moving through the magnetic field, and a downward force due to the weights of M and M, the two metal rods. Note that the tensions in the wire are internal forces and therefore not considered. The weight of M, big M, is larger than that for small m. Hence, the rod small m will move upwards. Based on Faraday's law, an EMF will be induced and result in a current because the system is a closed circuit. Based on Fleming's right-hand rule, the direction of the induced current will be from left to right. Using the same reasoning, the direction of the current in big M will be from right to left. The uniform magnetic field B is directed perpendicular to the rods and out of the paper in this diagram. For each rod, the EMF induced is equal to BLV. So the net EMF around the circuit is generated by both rods, so equal to 2 BLV. Induced current in the circuit is given by the ratio of the voltage against resistor, which is 2 BLV divided by R. So the magnetic force on each rod is BIL and is given as 2B square L square V divided by R. At terminal velocity, the net force on the system is 0. So the upward force 2BV must be equal to downward force big M minus small m times G. So substituting the values, I get the terminal velocity as big M minus small m times G and R divided by 4B square L square.